We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.
Lecture on partial differential equations. So in this first part, I'll briefly introduce to you the concept of partial differential equations and the classification of first order. And I will also share some facts with you on the nature of the solution of first order partial differential equation. So you're welcome to the online part. So let's consider this definition. Let's consider this general overview. Any mathematical expression that we actually use to model phenomenon is what we refer to as partial differential equations. This is more complex than ordinary differential equation. It's more complex in the sense that it contains some variables that we cannot find in ordinary differential equations. So we use this to model Brownian motion. At the same time, we use this concept of partial differential equation to model theory of stochastic processes. This is very common in statistics. And at the same time, when we're talking about disintegration, radioactive disintegration, we also use the concept of partial differential equation. And at the same time, if we want to study noise in telecommunication, we also use the concept of partial differential equation. Likewise, population growth, gas dynamics, and then traffic flow, including telephone traffic. All these aspects, all these phenomena, they actually deals with more than one independent variable, and that is the beauty of partial differential equations. It contains a mathematical expression and a derivative that is more than one dependent variable. So let's take a look at the general definition. This is only for first order, and you can see in this first order we're just talking about a kind of expression that will contain the independent variable x and y. Z is the dependent variable, and then the partial derivative of the dependent variable with respect to the two independent variables. So this is just a kind of definition for first order partial differential equation. Don't forget the key point here is that we have two independent variables and we have one dependent variable here, and we also have a derivative for the dependent variable with respect to the independent variable. So as you can see here, it's just like a mathematical expression, but note the following. So but don't forget, it's very possible for us to have one dependent variable and we have three independent variables, because the definition is for two or more. So two or more independent variables. So independent variable can increase more than three. It can be four, it can be five. But don't forget that in the case of ordinary, it is just only one independent variable. In fact, we can also see something like this. It's also called PD. In this case, you now see that we have UVW to be the dependent variables, and we have XYZ to be independent variables. So this is the best definition. This is one of the definition or acceptable definition for PDE, partial differential equation. So let's consider for order. So you can see now that here the derivative is 1, the derivative is 1. So we can call it first order. Look at this one to first order, look at this one to first order, look at this one first order. But you notice that all the four, they are different. Oh, so let's classify now. You can see in this one that we have the derivative standing alone. So we call this one linear. So this one is linear. Linear first order, PDE. No, it's first order, but we call it linear because we have the derivative standing alone. And we call this one semi-linear. You can see that this part is actually linear, while the other part is non-linear. So we call this one semi-linear because one part is linear, while the other part is non-linear. So it's just like a kind of mathematical expression that contains both linear and non-linear. But we can see that here we can differentiate totally. Because the first part is linear, while the second part is non-linear. So let's take a look at another example which is called quasi-linear. In the case of quasi-linear, we always have the unknown variable that we're looking for, which is z, to be multiplying the derivative. And most times it's always one side. Most times that's how we classify quasi-linear. Now let's talk about non-linear. In the case of non-linear, we can see that we're having the derivative of the unknown function multiplied by the derivative. So this one is pure non-linear differential equation. Partial differential equation. Okay. So how do we talk about the definition? The solution of first order. Now look at this expression again. I know you are familiar with this now. I have shown you this one to you before. That is just like a kind of mathematical expression for first order. You can see that the derivative is first. The derivative is first. We have x, y, and z. X and y, they are the independent variables. Y, z is the dependent variable. So now, if we can have a particular z of x of y, which is a kind of a function in this domain, and in such a way that that function is of C class in that domain. So there are two things involved that we must put into consideration. One, for every point x and y in that domain, the point, this one, is also in the domain of the function. What do I mean by that? That by the time we solve this one, we have the particular function z. If we differentiate this and return it back and we evaluate, what we are going to come up with will be a point inside this domain. It won't be outside the domain, it will be inside the domain. Another thing is that if we differentiate the function, you return it back, what you have will be expression of x or y. Do you know that in this case, by the time we know our z, we can differentiate z with respect to x. We can differentiate that z with respect to y. So by the time we put it back into the function, into the expression, what we have will be just only x and y. Z will not be there again. So, and it should surely satisfy the problem. So that is one thing we actually must notice about the nature of solution of first order PDE. So let's go to the theorem. Now this theorem A, this problem A is for the transport equation. Transport equation, and the theorem is saying that if we have this to be the problem, then the solution is in terms of a function of x minus vt, where this v is a constant and this f is just a function. It's just a function. So as you can see now that if v is 3 now, then you can see now that the solution will be what? F into bracket x minus 3t. So in our next video, in our next lecture, I will explain to you more about this, where we're going to use this theorem. So you will see that there are some questions at the back which I expect you to respond to. Thank you very much. Bye-bye.
We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.